the last video, we made it through the primary bronchi, secondary, and tertiary bronchi. Past all of that branching, we will make it to bronchioles. Bronchioles lack cartilage. They are 1 millimeter or less in diameter. The portion of the lung ventilated by one bronchiole is considered a pulmonary lobule. They are lined by ciliated cuboidal epithelium, and they have a well-developed layer of smooth muscle. And one bronchiole can divide into 50 to 80 terminal bronchioles. Now, considering we're still branching and branching and branching, getting smaller and smaller and smaller. The final branches of conducting divisions. Remember, conducting was just the air flow or airway, no gas exchange. These terminal bronchioles measure a 0.5 millimeter or less. They don't have any mucus or goblet cells, and so they do have cilia that's moving the mucus, draining it back into that mucociliary escalator. And then each terminal bronchiole gives off 2 or more smaller respiratory bronchioles. The respiratory bronchioles have the alveoli budding from their walls, and this is the beginning of the respiratory division. They divide into 2 to 10 alveolar ducts, and at the end of those ducts are alveolar sacs. They look like grapes, grape-like clusters of alveoli that are arrayed around the central space called the atrium. There are 150 million alveoli in each lung, providing about 70 square meters of surface area for gas exchange. So that round grape-like structure allows a larger surface area for our gas exchange to occur. The cells of the alveoli are squamous alveolar cells. They're called type 1 cells. They are thin, broad cells that allow for diffusion to occur very quickly between the alveoli and the bloodstream. This is 95% of our surface area of the alveoli. And then there's also type 2 cells called great alveolar cells. They are round to cuboidal cells that are the remaining 5%. And they repair that epithelium when the type 1 cells are damaged. They also secrete what's called a pulmonary surfactant. It's a mixture of lipids and proteins that coat the alveoli and prevent them from collapsing during exhalation. There's also alveolar macrophages, which are also called dust cells. They're actually the most numerous of all the cells in the lung, and they are wandering in the lumen, that's the opening of all of those bronchioles, and the connective tissue between the alveoli. They keep the alveoli free from debris by taking dust particles in by phagocytosis. And 100 million dust cells die each day as they go up that mucociliary escalator and eventually are swallowed and digested with all of their debris inside. Each alveoli is surrounded by, this says a basket. I don't know, I think of it like a net of blood capillaries supplied by the pulmonary artery. The respiratory membrane is that barrier between the air and the blood and in each alveoli. And that contains of squamous alveolar cells and then endothelial cells of the blood capillary. They share a basement membrane. There's kind of what I mean by a net. See how it's like a net covering each of those little grapes? And so that capillary network surrounds each alveoli, and that's where the gas exchange is occurring. And we'll talk about that in a separate video. Fluid in the alveoli would be a problem. The gases diffuse very slowly through a liquid, but the alveoli are kept dry by absorption of excess liquid by the capillaries. And so the lungs have a more extensive lymphatic drainage than any other organ in the body. Low capillary blood pressure also prevents the rupture of that respiratory membrane. So there's kind of an up-close look. Again, we're going to have a separate video about the gas exchange, but that shows you where the respiratory membrane is in between the air and the blood. And you see that the blood or the oxygen is moving from the air into the blood, and the carbon dioxide is going in the opposite direction. Okay, one last little bit of anatomy is the pleura. The visceral pleura is the membrane that covers the lungs. And the parietal pleura is what adheres to the mediastinum, which is the inner surface of the rib cage. Now, there's a point where this is a continuous kind of membrane. So where the visceral pleura kind of ends and curves, the parietal pleura begins. But there's a space in between them, and that's the pleural cavity. Normally, there's not really room between those membranes, but there's a film of slippery pleural fluid. And the pleura and the fluid reduce friction, create a pressure gradient, and provide the spread or prevent the spread of infection from one organ to others. So compartmentalization.